Hi guys. All right, today we're going to discuss about timer relay functions and the configuration. Okay, now this is the actual pictorial view of the timer. This is the pilot lamp we're going to use to illustrate the functionalities of this. So the essence of this wiring diagram in 3D component is because most of our trainees, they don't know, they've not seen the physical structure of this component, including this. So when you say pilot lamp, they need to see the physical structure, how it looks like. Then this is cam switch, which I will use to send the signal power to the coil of this timer, while it will now time and give us output. But we have two functions of timer. One is on delay, one is off delay. Like I have done here, I will explain later. The function I want this one to perform is that when I energize this timer, I want this load to come up. Then how long will the load remain on is going to be dependent on the preset time of this particular timer. The preset time is going to be 3 seconds. Let me see. Yes, let's say 3 seconds. 3 seconds is okay. Okay, now let's simulate this function like I just explained. Watch this play, you see them come up, all right? I put on the load, you see them on, then it start counting. Now, after preset time is shut down. Now, another configuration again is this. I can change this configuration by looking at the symbol. Now, take a look at this. Now, the timer of this, the terminal that give me the output here is coming from terminal 3. That is normally closed. I put it on normally closed, NC. If I change this terminal now to NO, that means if I put on the timer, this one will not come up. It will start timing after preset time. That is when the output will be energized. Okay, so that is the configuration of this. So the reason why I decided to put the pictorial view, the 3D dimension, is for you to see the wiring diagram. Okay, now let me explain the most essential part of this design. This is a schematic. Okay, this is timer 1, timer 2, timer 3. They does different functions. This one is on delay timer. This one is off delay timer. This one is on delay stroke off delay. This one does two functions. The first stage is to delay to on like this. The second stage is to delay to off like this. So it does the two functions of this. Okay. So the name here is multifunction timer. Okay. This one is off delay. Then this one is on delay. Then this one is on delay stroke off delay. But you have to set it. This one has multiple settings. How you want it to be. It can be 24 hours timer. Okay, this particular one. It can work 24 hours depending on your setting. Okay. Now let's quickly simulate this. I energize this. It start timing. When the time elapses, it gave me load. Look at it. So this one closes. Now, take a look at this timer again, the symbols. This one symbol is the strike by the side. This one symbol is the solid shade. This one combine the solid shade and the strike like this. That is the symbol. Now, their contact also, their symbols are different. Look at this symbol. This symbol maintain the two half moon combined together. The two half moon combine here to form the symbol of this. This one maintain one side of the half moon, the right side. This one maintain the left side of the half moon. So this is how you denote their symbols. Okay. By the time you register for the course, we're going to teach you symbol, how you understand symbol, and how you plot the symbol to form a particular function. You know, like I always advise people, when you are coming to automation career, you must come from a control system perspective. You must understand control system first. Control system enables you to use logic control, relay logic to control a particular function, to control a particular process. Okay, such as, for instance, I want to design a panel to control my door or electric gate. I will make sure I design the panel such that I integrate timers, I integrate sensors, and I integrate other electronics components, such that when I come close to the door, a sensor should sense my presence and open the door. When I gain access to the entrance, then the door should close back. These are how to manipulate relays to do such function. So you should familiarize yourself with the functions of this component before coming to automation, because when you come to automation, the control hub of automation has to do with automation control. Control aspect of automation is the most challenging aspect of automation, not writing the code. Writing the code is just like ABC, because writing code, you must know what you want to control before you now write the code to configure the function and now download it to PLC. PLC now work and now send the signal to the control panel. And let me also remind us, automation cannot function effectively, not even effectively. Automation cannot function without control. You must control the automation. How do you control automation? Is by communication from a PLC to a certain device or few devices. You must interface automation, a PLC with a panel. That panel must be enclosed with some components such as this, contactors, relays, and so on. So you now interface that particular function of this control with your PLC. PLC control this, and this one finally give you the result to the field instrument, to the field operation. All right. But I also, let me even show you the automation. This is software. Okay. This particular software, I have this load to control using timer. Okay, let's do that. Let's do that. Okay, let's do that. Now I put on my control. I put on my, let's see if we can simulate. Just hold on. What I've done in the other control is what I want to also repeat here. Okay. Sorry, let me quickly download. Okay, just hold on. Let me perform the similar thing I did in control software. Now I want to control this load using this timer. Let me put it on now. I put it on. The load come up. Motor 1, motor 2, motor 3, they are running. After preset time, it shut down. Simple, it shut down. The same instruction I did on control is the same thing PLC do, but different configuration. I write code. I use this one to write code. You know, you must write the code. Understand? Let's go back to control software. Now, similar thing that I did in automation software is what I have done here before. Okay. Sorry, shut down this. Okay. Now, so make sure you familiarize yourself with the configuration of component so that when you now come to automation to write a code, you don't find it difficult. It will just be very easy. You know, for instance, I give you example. You want to design ATS. You design ATS, put up instruction that this once this power is available, please activate my load. When this power is working for a preset time, please shut it down, activate second the gen to come up. So that instruction will be embedded in timers and the sensors, you know. So sensors and timers and other multi-controllers and modulars will do their function right inside the ATS. But now that same function can be downloaded into PLC. Write that same code in PLC, telling PLC put on gen 1 so time, shut it down, put on gen 2 so time, depending on whatever thing you want the PLC to control. So if you want to go into automation, you must come from a control perspective because you must write your code in PLC according to what you want to drive. So, but if you don't understand what you are doing, that means you're going to do copy and paste. There's a training called copy and paste. You do according to your instructor. Instructor say do this, you do that. Do this, you do that. So without your instructor, you cannot do anything. You cannot be creative enough to design a particular function, a functional process. But if you come from control perspective, it's as if, for instance, you are an architect. Beautiful. Yeah, an architect. You design your building from structural, from the foundation to the roof level. You use your hand to sketch, to make your load analysis, to do your design analysis, everything. You do it yourself. So when you want to go to AutoCAD, to learn AutoCAD, what AutoCAD will give you is the tools to do that job faster. This is just typical example I'm giving you. Please listen again. An architect want to use AutoCAD, a software, to design buildings, to make it faster so that the more you do with manual, you can do it 2 weeks. But with AutoCAD, you use 3 days to accomplish that same job. So AutoCAD is not architectural designer. AutoCAD is just giving you tools to enable you deliver your job faster and more precise,